Okay, I'm back after the phone call, which turned out to be fairly important, so that's good. And then also I took the time to show a portion of the unit circle here in the first quadrant. And if you know this portion, you can find all the others. So all we need really is this part here in the first quadrant. Even though cosine of 225 is not in the first quadrant, that's okay. So what I'm going to do, first of all, I'm going to find where cosine, or where 225 is. I'm going to find that reference angle. So let's see, we start here. Of course, we go around to 180, and then it's another 45 degrees past that here. So this is 225 degrees, which means our reference angle would be 45. So there's a reason we went to all that trouble learning about those reference angles, because we're going to use them as referenced. So cosine of 225, since its reference angle is 45, the cosine of 225 will be the same as the cosine of 45. But we'll also take the sine into consideration, which quadrant it's in. So we'll have to talk about that as well. There's all kinds of things to talk about. So first of all, let's find cosine of 45. And to do that, I've drawn a portion of the unit circle, which we will memorize, and I'm going to show you the hand trick, so it's actually really easy to remember, as long as you can remember the hand trick. Again, remember pi over 6 is 30, this is 45, and pi over 3 is 60. So since I'm finding cosine of 45, that's right here. Recall that cosine is the x-coordinate, root 2 over 2. Of course, in this case, it wouldn't matter one way or the other. Both sine and cosine of 45 are root 2 over 2. Now, there is one other thing that's not necessarily the final answer. We also have to take into consideration which quadrant we're in. So we are in quadrant 3. If you were plotting a point, just like on the regular, like some xy point, how do I want to explain this? The cosine is the x, right? The x-coordinate. Well, the x-coordinates are going to be negative over here on this side, right? So that means cosine in this quadrant 3 will be negative. Another way to remember that is all students take classes. When I do all students take classes, I start in quadrant 1 and I work counterclockwise. And the first letter of each one of these tells me which trig functions are positive in that quadrant. So in quadrant 1, they're all positive. A is all. In quadrant 2, just sine is positive, and its reciprocal cosecant. In quadrant 3, t for tangent, so tan and its reciprocal cotan are positive. And then in the fourth quadrant, c for cosine, so cosine and its reciprocal secant are positive. So notice sine's the y values. The y values, if you were just plotting points, the y's would be positive above the x-axis. So in both the quadrant 1 and 2, sine would be positive. And then tan is y over x. So if I'm in quadrant 3, both my x and my y are negative, right? But if I have a negative y over a negative x, that ends up being a positive. So that's why tan is positive, and so is its reciprocal in quadrant 3. And everyone thinks positive in quadrant 1. All right, let's move on. Oh, I'm going to need this unit circle again, aren't I? Well, I'm going to trust that you have this written down, and I'll just use my hand trick and kind of talk along about this. So tan of 5 pi over 6, first of all, figure out which quadrant it's in and find its reference angle. So as we talked about with the paper plates, you're thinking this is in 1/6 of a pi, so you're dividing from 0 to around here to pi. You're dividing this into sixths, 1, 2, 3, 4, 5, and then 6. So each one of these is a 1/6. Pi over 6, 2 pi over 6, which is the same as pi over 3, 3 pi over 6, which is the same as pi over 2, 4 pi over 6, which is the same as 2 pi over 3, 5 pi over 6, and then 6 pi over 6, which is the same as pi. So tan of 5 pi over 6, here's 5 pi over 6, and then we find its reference angle, because that's what we need to use, and that would be pi over 6. because I counted in sixths of pi. Each one of these is pi over 6, so this one's pi over 6. Or if you don't like that, you can do pi minus 5 pi. That's a 5. You could do this pi minus 5 pi over 6 to get the difference between them, which is pi over 6. Okay, now on the unit circle, so pi over 6 is this one, and let's see, I have to remember what those are. That's going to be, I used to use my hand here, which you can't see, root 3 over 2, and whoops, oh, it never wants to write right there. 1/2 is the y-coordinate. So when we're doing tan of pi over, this is pi over 6, tan is y over x. You have to memorize that. So if I use this point, the y is 1/2, the x is root 3 over 2. So then I have to multiply by the reciprocal of the denominator. So all this stuff we've learned this year is all being used here. Cancels out, I get 1 over root 3. When I rationalize that, I have root 3 over 3. Then I have to check the sign. So 5 pi over 6, 5 pi over 6. That's in quadrant 2. If you do all students take classes, only sine is positive in the second quadrant. So that means that tangent would be negative. So the answer is negative root 3 over 3. Okay, next. Okay, this is on your own, so you can pause the video and you can do this one on your own. And then I will do it too. Maybe I'll just give, to save time, I think I'll just give the answer. I have to find it here in my notes if I even have it. Okay, this one is negative root 2 over 2. Tan of 180, I'll talk about that one. 180 is right here. That's the point negative 1, 0. Tangent is y over x. So in this case, the y is 0. The x is negative 1. So that's 0. What if we wanted to know cotan of 180? Well, cotan is x over y. So in that case, it'd be negative 1 over 0. And as we know, that's undefined. So cotan doesn't have a value at 180. It's undefined. Turns out you can graph these. You'll do that next year in pre-calc, and it has an asymptote there. I could show you a little sneak peek. This is what, let's see, tan looks like, this is tan. Tan actually looks like that when you graph it out, believe it or not. See, it has asymptotes at certain values. So that's a sneak peek of what you're going to do next year. Okay, cosine of 4 pi over 3, that one is, again, do this on your own, but the answer is negative 1/2. I already did all students take classes. We have been doing this along and along, so I can give you this answer as well. I just have to find it in here. Oh dear, I don't even know. I guess I'll have to do it on my own, because I don't know what. Yeah, let's just do it. So 330, that's all the way around to here, with a reference angle of 30 degrees. So, of course, I want to use my hand, which I'm going to be showing you guys later. So 30 degrees, that's here, and we want to do, we want to do all of them. So sine of 330. So sine's 1/2. Cosine is root 3 over 2. I'm using my hand, and I'll show you guys this. Tan is y over x, so that's cosine or sine over cosine. Those 2's are going to end up canceling. You're going to have 1 over root 3, which is the same as root 3 over 3. And then you have to do your sine. So all students take classes. Only cosine is positive. These other 2 are negative. So I did that pretty quickly using the hand trick. Okay, 270. That one's going to be pretty quick because it's a quadrantial angle here on the quadrant line. That's 0, negative 1. Sine is, whoops, I should have done 270 there. Sine is the y value, that's negative 1. Cosine is the x value, that's 0. Tan is y over x, negative 1 over 0, so it's undefined there. Holy Toledos, there's a lot of these. All right, let's see if I already have this one in my notes. Otherwise, I have to work it out because I don't have these memorized, of course. Okay, I don't see it in my notes. I think these slides are a little different maybe than the ones in the book. That's fine. 11 pi over 6. That's, so 12 pi over 6 would be 2 pi, wouldn't it? So 11 pi over 6 is 1/6 of a pi less than 2 pi. So that means it's right here. So pi over 6 is my reference angle. This would be 11 pi over 6. Okay, of course I'm going to use my hand trick. So this is 11. I'll write it all out. You can also do all students take classes ahead of time and figure out the sign. So all students take classes, cosine is positive. These sine and tan are going to be negative. And then using the hand trick, pi over 6, sine is again 1/2. This is just like the one we just did, isn't it? Cosine is √3 over 2. And look at how slow so y, I already forgot what the answers were. Okay, that's going to be 1 over √3, which is √3 over 3. So there are the answers for that one. I'm just curious if these are in the book. Oh, they are. 11 pi over 6 is in the book. Okay, that's where they came from. Oh my goodness, there's more. You know what, I'm going to skip this because I need to move on. I'm running out of time. Okay, arc length. There's a formula, it's S equals r theta. The important thing is theta must be in radians or it will not work. Let's do a little quick proof of this. Here's a circle. Let's say this is theta and S is the arc length. So S is this length of the arc. And I'm going to do a quick proof of where this formula comes from. So remember from in geometry, when we found arc lengths, we made a proportion. And we did the angle that we are given, in this case theta. We compared it to the entire circle. We used 360 last year. This year I'm going to use radians. So all the way around once is 2 pi equals. And then so that's the angle, and then on the other side I'm going to work with the lengths. So this theta is associated with the arc length of S, and then the 2 pi is associated with an entire circumference, which would be 2 pi r, because the circumference of a circle is 2 pi r. Now the 2 pi's will cancel out, and I'm going to multiply both sides by r, and look at this, those will cancel, S equals r theta. So, and you can see I use radians here, I use 2 pi, that's why this theta has to be in radians. So S equals r theta. And now we'll use that example, or that equation rather. Actually, I don't even know that I use it exactly, to be honest. A tire of a car makes 653 complete rotations in 1 minute. The diameter of the tire is 0.65 meters. To the nearest meter, how far does the car travel in 1 second? I like to use dimensional analysis myself. So to do that, you start with what you're given. 653 rotations, that's I call a revolution. Revolutions in 1 minute. So that's a rate. And I know that the diameter is 0.65. I was just kind of thinking of how I could relate this to the S equals r theta. Well, you could find r and then I don't know, I'm just going to do it this way. If you don't like the way that I'm doing it, you can look in the book and see how they do theirs, and maybe it'll make more sense. So anyway, what was I doing here? Now I lost my train of thought. Oh, I hate it when I do that. So, 653 revolutions. Oh yeah, let's convert revolutions to, in this case, meters. So 1 revolution, if you go 1 time around the tire, that is going to be its circumference, which is 2 pi r, or in this case, pi d. So pi times the diameter of 0.65 meters. So Every revolution it goes, it travels this far. The wheel moves like the length of its circumference. The revolutions will cancel. Now I'm in meters, which is good. I'm now in meters per minute, and I need to get meters per second. So I need one more conversion. And I'm going to convert minutes, so I need to put minutes on top. And I'm converting those to seconds. 1 minute equals 60 seconds. Cancel, cancel. And notice I have meters per second, which is exactly what I want to know. I want to know how far it goes in 1 second. So now I can go to my calculator and type this in. Okay, so I'm going to have 653 times 0.65 pi. I hit enter, divided by 60, enter. 22.22. It says how far to the nearest meter, so I'm going to round to the nearest whole number, which is 22 meters. I didn't even use S equals R theta. Oh well. Dimensional analysis, man. Sometimes it'll help you out. You don't even need to use a formula. A minute hand on a Big Ben clock is 14 feet long. There's a radius right there. To the nearest tenth of a foot, how far does the tip of the minute hand travel in 1 minute? So I'm going to just kind of think about this. On a clock, this is the hour hand. It travels all the way around in 1 hour. So in 1 minute, it's going 1/60th of the way around. And all we really need to figure out is 1/60th of the circumference. That's pretty straightforward. And the circumference is 2 pi r, 14 feet. Just kind of making sure this all looks good. Yeah. So on the calculator, I'll just do 28 pi, 2 times 14, 28 pi divided by 60. So about, and it says to the nearest tenth of a foot, so 1.5 feet. That's a pretty big clock, isn't it? But in 1 minute, it's already gone 1.5 feet. Oh, with it on the end here. Great, so we'll see you in class.